So in part 2 of motion, we're going to be looking at speed and velocity. One's a scalar, one's a vector. It actually matches up. So speed's a scalar, velocity is a vector. Let's take a look. This is your very first formula. Formulas are really important in all of sciences, okay? This is what we're looking at is speed. Remember, it's a scalar value. So it's a rate. By the way, a rate is anything per time, okay? So it is a rate at which an object crosses a distance. Remember, we learned distance was a scalar as well, with no reference to direction. However, notice in this formula, it's a little bit odd because it still has a V instead of an S. Sometimes you may see people write it as S equals D divided by T, and that's perfectly fine. They're just using an S to represent speed, but the true formula is exactly the same as velocity except for one key difference, which I'll get to in a little bit. Also, I'll come back to it, but notice that I have this lovely pyramid. That's because I'm going to go in why a formula is so important, but this is a little cheat we'll come back to after I get to why a formula is so very important. So we have our very first formula. Speed is equal to distance divided by time. Now, a formula like this is really, really important because it tells us a mathematical relationship. See, we have our equal sign and divide, but it tells us the mathematical relationship between real-world items. So speed is always going to be equal to distance divided by time, right? And yes, it doesn't have any numbers, but you can substitute any numbers of anything you have in any three of these variables. That's what we call each one of the letters that represents a whole word. So this V for speed, this D for distance, the T for time. And that's going to show us how we can calculate it. So if I have a distance of, say, let's put this over to the side. Let's say I have a distance of 4 meters, and I do that, I cover that amount of distance in 2 seconds. Well, that's going to give me a velocity of 2 meters per second. Notice how it even combined the units over here. That's also kind of a big deal because that setup shows you how your units are going to be meshed together to get a new unit for this. All right? Now, the brilliant part about all of this is that that doesn't just show us one relationship. It doesn't just show us how to get velocity. But instead, I can then use that formula that we have here, and I can make it mathematically equivalent to solve it for any one of my other variables. So I can solve it to where it equals just D or just T. Right now it equals just V. And it's basically doing the opposite of whatever function it's already been doing. So the way I learned little algebraic expressions back in the day was equal sign is a gate. You have to herd all the other animals except for the one that you want across the gate. You get them across the gate by doing the opposite of whatever function is currently been doing to them. Now, if you have something like this, which is a division, you can't multiply by the one on top. You can only multiply by the one on bottom, okay? So we can move the T by multiplying this side by T, right? Because anything that is both divided and multiplied by the same thing, it's going to equal 1, which means it's not going to do anything to that value. So essentially what we do is we get rid of that. But in order to do it to one side, whatever you do on one side of this, whatever you do on that one side, you have to do to the other side. So that means since we multiplied the right side by T, we also have to multiply the left side by T. And that's going to give us a brand new thing. We now have And I'm just going to rewrite it that d, because it's all by itself, is equal to velocity times time. So we've solved it now for yet another one of those equations, okay? But now that we have it there, we could also solve it for t. That means that if I want to get t by itself, right here, I have to get rid of v to the other side. I have to move it across. It's being multiplied, so I would divide the side by v. So let's do that. I'm going to now divide by v on this side. T is now being multiplied and divided by v, which means it cancels each other out, and we don't have to worry about it. But we only did that on the left side, so now we got to go back to the right, and we also have to divide it by v. What that's going to do is it's going to make it to where we have yet one more whole new problem. We're now going to have t is equal to d divided by v. So now we've solved it 3 different ways. So what this essentially means is that in that one equation that I have, the speed equals distance divided by time, I now really have 3 equations. Distance is equal to speed times time, and time is equal to distance divided by speed. So we get 3 for 1. Now, I know some of you don't really love the whole mathematical solution to this. So in order to get those 3 equations, we have a little cheat as long as the formula is simpler, okay? So as long as it's simple and only 3 variables, you can use a triangle. You're going to draw a triangle just like this one, and then however that first one is set up, you're going to put what's on top, and what's on bottom. So in this case, we would have speed there, distance there, and time there. This shows a mathematical relationship too. For instance, anything that's side by side in the bottom will be multiplied when we look at those. Anything that's sitting on top of each other will be divided if we need those. Now what you do is you take your hand and you cover up whichever one you want to solve for. So if I was covering up v, I would then write out v equals. V equals, and then I look at what remains. So if I cover up v, I then need to figure out what the rest is there. And what I have, let's draw a better one. What I have is d equals t, right up here. Now, if I wanted to cover something else up, I could cover up the d, right? Let's cover it up this time. All right, so I cover up my d, and what I'm left with is v times t. And so I get that other equation right here, d equal to v times t. Or I could once again, see if we can undo it, cover up t. Let's cover up the t this time. And that's going to leave me with d divided by v, which you can see right up here. T is equal to d divided by v, or by speed, distance divided by speed. And that's how you mathematically arrange an equation. So the next thing you need to remember is we have SI units, right? For those units, your distance, time, and speed are all going to be part of your formula, and your units, you should be using meters for distance, seconds for time, meters per second, written that way, for speed. However, it's still a speed if they don't use the SI units. The SI is just special for science. So if they write kilometers for distance per hour, you can get kilometers per hour for your speed, right? You could get centimeters per second, you could get miles per hour. All of those are still speeds. Notice they don't have direction with them, but only one is the SI unit, meaning the proper one you should use for science, okay? This is just another look of that breakdown. And the fact that we're going to be looking at velocity is going to be the exact same formula as the speed formula. That's why we actually use that v for it. In fact, let's look at that formula. Notice in this formula there is one thing different. They write it funny. Don't get confused by the way that it's writing, because it's still a speed. It's still a rate at which an object changes position, only this one has a direction to make it a velocity because it is now a vector, right? Remember vectors? Okay, so if you're looking at this, that v with a line over it, that means vector. That line over top of it tends to mean vector. That's how we know we're now talking about a velocity. Don't get confused or scared by that little triangle either. That's just a Greek letter called a delta, which means a change in distance or a change in position, which is a displacement. So now we're talking about a displacement. They put one with time too, but to be honest, that's more of a mathematical thing that's above your level. Just know that a change in time is always going to be the amount of time. It doesn't have a direction. With displacement, it could have a direction.